Okay. In the video, did I leave off at example 3?
You had example 3. That's all example 4.
Okay, so example 4. Okay, you have to be really careful on these because we are going to rewrite this sequence so that we can recognize what type it is. It's very easy to make mistakes on this type of sequence, well, series in particular. So if you think of this one, we're going to rewrite this and we're going to say this is the same as 3 times 1/2 to the n. How is that the same?
Because it's over 1/2.
Yeah, so it's being divided by 2 repeatedly, right? Being divided by 2 to the first, being divided by 2 to the second, being divided by 2 to the third. That's the same thing as multiplying by 1/2 repeatedly. Dividing by 2 and multiplying by 1/2 are the same thing. All right. Now that it looks like this, can you tell what type of series it is? This is geometric. All right, so I'm going to write geometric. What's the r value? So geometric, r is 1/2. And since the absolute value of r is less than 1, what is our conclusion?
That it converges.
It converges. This converges. How do we find the sum that it converges to? You find the first term, which is 3 over 2, right? 3 times 1/2, so 3 over 2. That's the first term. Divided by, 1 minus r, which is 1 minus 1/2. Okay, so 3/2 divided by 1/2 is 3. So this converges, and it converges to 3. All right, this next one is going to be 3 over 2 to the n power. Is this geometric, telescoping, or is this one where we have to try that nth term test?
No. Geometric.
It's geometric.
Yeah.
How do we know it's geometric?
No.
Yeah, when in doubt, you could just write the terms out, right? That's a rhyme. So the first sum would have been 3 over 2. The second one would have been 3 squared over 2 squared, and then 3 to the third over 2 to the third, and then 3 to the fourth over 2 to the fourth. And if you write your terms out, you can see the top numbers multiplying by 3, the bottom numbers multiplying by 2. And that means it's geometric because our pattern is multiplying, and it's multiplying by the exact same thing every time. It's not multiplying by different numbers every time, it's the exact same. And that's what makes it geometric.
So multiplying by different numbers?
Like let's say the pattern wasn't multiplied by 2, and then it multiplied by 3, and then it multiplied by 4, and then it multiplied by 5. You would say that your pattern is a multiplication pattern. However, it's not geometric.
So geometric is just a
It
constant.
has to be the same thing. So this is geometric. The r value is 3/2. And since the absolute value of r is greater than or equal to 1, what do we conclude? It diverges. These numbers get bigger forever, so if you added them up, what sum would you be getting close to? Infinity, yeah. So we would say it diverges, and it happens to diverge to positive infinity. But that's not like a legit number that we can say, like, yes, it's going to get there. So we say it diverges. All right. Number 6. This one is going to look a little bit weird. It is 0.08080808080808. It's a trick. You could have done it just once. It's just funny. Because it was funny how many times you guys let me keep saying it. I don't know. It was entertaining.
I thought she was trying to make like an echo effect, so I just thought, okay.
08, 08, 08.
Yeah, it's okay. But you never like your voice going.
All right.
I'm gonna get right. I like.
So this is how you write a sequence or a series out like this. Are you guys ready? Because this is actually where some of the geometric sequences come from. It's actually geometric. So here, if we look at the first two numbers and we write them as a fraction, this is 8. And then what spot is the 8 in? 100th. So this is 8 100ths plus. So this is the decimal 0.08, right? But I don't just have that decimal, right? I've got another 08 after it.
Oh, no.
So if I wanted to say plus 0.00, because I already used these ones and then got another 08.
It's going to be 1,000.
So this would be 8 over 10th, 100th, 1000th, 10,000th. Okay? So that would be like if I added those two decimals together, then I would get the first 4 digits. Do you guys see how it's working? Okay? And then I'm gonna keep going. 8 over 10th, 100th, 1000th, 10,000th, 100,000th, millionth. Okay, let's not keep going, but can you see what the pattern is?
No.
The top stays 8, right? So you're multiplying by 1 on the top. What are you multiplying by on the bottom? How many zeros are being added each time? 2. So how do you add 2 zeros on the bottom? Multiply by 100 on the bottom. Okay, so this is a geometric series, and the R value is 1 over 100. You guys see that? Okay. So if we wanted to write down what this summation would be, we would say the summation from 1 to infinity of 8, right? That would be like your first term. That's the thing that has to get on the top. Times 1 100th to the nth power. Do you guys see how we're doing that? So the first term would actually be 8 over 100. And then after that, we would just multiply by 100 on the bottom every time. And that's how we get all those 8s in there. All right. So if we look at this one, we're going to say this is geometric. The R value is 1 100th. And what is our conclusion if R is 1 100th? It converges. And how do we find the sum that it converges to? 8 over 100 over 1 minus 1 100th. So you have 8 100ths divided by 99 100ths, which is 8 over 99, because the 100s cancel, right? Ta-da. Isn't that kind of cool when you look at those repeating decimals? Do you guys think that's kind of cool?
It's pretty cool. I think it's kind of cool, but doing this is...
You don't like this?
It's kind of confusing, but I feel like once we start practicing, like,
Yeah.
even more...
I don't know why, but those repeating decimals, they kind of get me. I'm like, oh, that's cool. I don't know.
It's cool how they got that.
All right. Okay, here's the next one. Example number 7. In case you need to know that there's an end in sight, we're going to example 10. Does that make you feel better to know there's an end in sight? Yes. Or is that number too big? Sorry, 10 examples. Sorry. All right, example 7.
08, 08, 08, 08, 08.
N equals 1 to infinity of 2 to the n power. When you're not sure if it's geometric or not, your best bet is just write out some terms and see if it works. Like if it seems like it's geometric. So can you guys tell what this one is? Geometric, yeah. So I'm looking at this one. I'm like, this one is definitely not telescoping. What should we see if it's telescoping?
2.
Like 2 things, right? It's going to be like something minus something, something plus something, some canceling stuff. So between geometric and if it's the nth term test, it's just... You can just write out the pattern. If it's not consistently multiplying by something, then do the nth term test.
So telescoping, like, if you had an equation,
It would have like 2
say if
pieces
you have
to
like
it.
a quadratic equation in there, would that be telescoping or not?
It would depend, because telescoping is when you have like one number minus a number, and then plus where like terms are canceling out. Remember how that worked out in the notes from last night?
This number 2.
The telescoping was like this number was here and then these two canceled out. And then these two canceled out. So telescoping is going to be real specific. So if it's not telescoping, it's either geometric or you have to do the nth term test because we don't know how to do anything else.
So when you see like a telescoping problem,
Yeah, you're going to be like, oh, that's telescoping. Yeah. All right. So 2 to the n is definitely geometric. What's the r value? 2. R equals 2. And then if r is 2, what's our conclusion? Diverges. So if we added up the terms forever, what would we get? Infinity. 2 plus 4 plus 8 plus 16 plus 32. It's just going to get bigger forever. Your sarcasm hurts my feelings, sir. You should be like, wow, that's awesome.
Yeah.
Uh-huh.
Well, I have a question.
Yes.
At some time, did y'all ever go about how the zero,
Factorial?
Yeah, factorial is
How y equals 1?
Yeah.
No. And I don't know what that is, so I'd have to look it up.
Can we talk about it?
I'll get us started. We'll start the assignment for today. And then once I get finished, I'll look it up and see if I can
That's
find
kind
it.
of interesting.
I think it's interesting too, yeah. All right, so example 8, we're looking from 1 to infinity of n factorial over 2n factorial plus 1. This is one where you should say, is that geometric? No. Is that telescoping? No. Okay, so this is one where we're going to do the nth term. So I'm going to say this is not geometric or telescoping. I can tell because it looks weird. Let's maybe write down some of these terms, though, so that we can actually see what they are. And I'm going to be honest, I don't feel like typing this in repeatedly. So a good cheater way to get some terms real quick is to graph it. How do I get to the factorial? Does anyone remember? Hit the math button.
Oh, I thought it was one of the top. No, it's not 6. You got to move over.
Math button, go over to PRB, probability. The reason it's over in probability is that factorials are often found in probability formulas. So,
Find it in the little tabs at the top of the calculator too.
is it in one of those?
Yeah, you can try. It's like alpha. If you hit alpha and go to the tab.
It's F2.
Yeah, it should be.
Two?
There.
No, it's F3.
It's not one of those. I think it is.
Okay, maybe it's on F1.
I think mine's right. I think if you have like a. I'm pretty sure. But stop fooling with rice. I'm sorry. I was curious. I thought
All right, so I'm just typing this in the only way I know how, which is doing the math button. Sorry. So 2x plus 1. Wait, the newer one, like the color ones, you mean?
Yeah.
I wonder, that might mean, because these calculators have operating systems, it might mean that your operating system is more updated, and I could just, yeah, so I was going to say, I could just plug my calculator in and steal it. All right, so what I did, because I want to find some of these terms, but I don't want to type them in individually because I'm lazy, I just graphed it, and I'm going to look at my table and find a couple terms. So this is 1/3 plus 2/5 plus 6/13. So if you were struggling, wondering what type this was, when you write out the first couple terms, it makes it pretty obvious. It's not geometric or telescoping. You can tell pretty easily. Okay, so that means we're going to do the nth term test. And there's some limitations to the nth term test. What's the only thing it can tell you? It can only tell if it diverges. It can't tell you. So if it doesn't diverge, it doesn't mean that it necessarily for sure converges. It just means it's inconclusive. We're not sure. We don't have enough knowledge on the subject yet. So we'll be able to see maybe it diverges, but if the nth term test doesn't really give us results, then we can't do anything more about it today. So if we think about this, when we look at the limit as n goes to infinity of n factorial over 2n factorial plus 1, Is the plus 1 going to make any difference in our problem?
No.
No. So we just have to think about what would happen if we plugged infinity factorial times, or divided by 2 infinity factorial.
You got 1/2.
Yeah, you get 1/2 because the infinity factorials are like exactly the same size, right? And this one had a coefficient of 2, so this is going to equal 1/2. So the nth term test did not equal 0. So what's our conclusion? Diverges. So this did not equal 0, so it diverges. If it did equal 0, then we would say, I don't even know. We have no conclusions. So we know it diverges because it didn't equal 0. If it did equal 0, we would know nothing from the test. Yes?
And that's just, you just plug in the limit.
Yeah.
Plug it in.
Yep. Yep. And the reason we do this test is because it's like, aside from knowing that it's geometric or telescoping, it's like the easiest thing we can do. Of course, we're going to go on and learn what happens if you do the nth term test and you don't get any results, because we got to learn like what the other results are. So we're going to learn those. We're just not doing them yet because this is day 1 of this type of series, looking at these series. All right, example number 9. We got 10, so we got 2 more. Example 9. All right, so from 1 to infinity of 1 over n. What do you think? So let's write the terms out, right? 1 over 1, then 1 over 2, then 1 over 3, 1 over 4. So is it geometric?
No.
Is it telescoping? No. So we're going to say not geometric or telescoping. So what do we do?
I have a question. Do the test.
Yes.
How would I know by, like, just not from the equation, but how would I know from
The terms, which one it
that
is?
it's
Telescoping is like that example from, where did my paper go? The example from the video last night where like you have terms that cancel out. Like this term stays and then these two cancel, these two cancel. That's what telescoping is. Yeah. All right. So not geometric, not telescoping. That means we have to do the nth term test. So we're going to say the limit as n goes to infinity of 1 over n is 0. So what does that mean?
It means that
we
don't know.
We don't know. Inconclusive.
Inconfused.
It might diverge. It might converge. We are not advanced enough yet to know the answer to that.
Are you advanced?
I'm advanced enough.
Then what's the answer?
It diverges. You're going to learn why tonight.
Oh,
All right, example 10. I've been practicing that for 9 years. That's like...
Were you good at it your first year?
No, my students like throughout the years, because when I first started teaching, I used to teach year-long classes, and then my students might have me 2 years in a row. They're like, Ms. Rice, your laugh has gotten more evil as time has progressed. And then at this point, I feel like I just nail it. You know, like sometimes my friends are like, do you laugh like that for your students? Because you sound real evil, you know? Anyway, all right, number 10. We got a story problem, so stretch out your hand. We're going to write a lot. A ball is dropped.
What can I say about this? Oh, come on, dog. I don't got room for all that.
I'm sorry. Write real small. So you have like 1 line left? Because I know how you write.
Yeah, honestly, I've been using 2 lines for the last like 5 years. Oh my gosh.
A ball is dropped from a height of 6 feet and begins bouncing. The height of each bounce is 3/4 of the previous bounce. This might feel familiar because people usually use these with exponential story problems. Find the total vertical distance traveled by the ball.
So it's gonna be the summation thingy.
Can I give you a sheet of paper, Miles?
He wrote it in 2 lines.
No, I'm not even through 2 lines yet. I'm like through half of one.
Miles.
What are you writing
He's
on?
writing
But
like
is it-
2 lines in 1 line.
Yeah.
Are you kidding me?
He always writes like that, though.
Yeah, I had enough room. I probably could have wrote it, but I didn't know how long the problem was going to be. So I started writing
You
really
didn't want to do that.
Yeah.
That's what you said you had to
All
do.
right, so here's a picture.
See how many
Here's the ball,
See this why
and the ball
You have
bounces
to do this,
down
You could-
6 feet.
I don't think I can afford that much money.
The ball goes down 6 feet, right?
Martin, just make the ball high.
Because it's a height of 6 feet. And then what does the ball do after that?
Bounces up.
Bounces 3/4 of the distance. So it goes up and then 3/4 of the distance, right? So this height right here is whatever you get when you do 6 times 3/4. And this height right here is whatever you get when you do 6 times 3/4. Right? Yep. And then what happens next?
Then you gotta do 6 times 3/4 times 3/4.
Yes, and then it bounces again, and this time the height is whatever that was times 3/4 again. So it would be 6 times 3/4 times 3/4. And this height would be 6 times 3/4 times 3/4. So can you guys tell, if we continue the pattern, what type of sequence this is? Geometric, right? We're being repetitive. We're repetitively multiplying by the same thing, that 3/4.
Could you just like 6 times 3/4 squared?
Yeah, so that's what we would say for this one. So after the first bounce, you would say 3/4 to the first power. After the second bounce, 3/4 to the second power. After the third bounce, 3/4 to the third power, and so on. So for my sum, I don't know why I wrote a plus, sorry. The sum is going to be the 6 feet that you started with, right? Because you dropped it 6 feet to start with. And then we're going to have 2 of these. You guys see how it goes like up and then down, and it's like the same each time?
Yeah.
Okay, so I'm going to say plus 2. There's double of that. And the summation that I'm doing is 6 times 3/4 to the n. So the first bounce n was 1. The second bounce n was 2. The third bounce n was 3. But there was 2 of them each time, 1 on each side as the bounce goes up and then as it comes back down. Does that make sense how I came up with that formula? Okay. And then technically it bounces forever, although we know, like realistically speaking, the ball would eventually stop. All right, so if we go ahead and evaluate this, we can use what we know about properties of series. So based on what we know about properties of series, what can I do with this 6 right here?
You can take to the front.
Yeah, I can move it to the front. Okay, so I've got 6 plus 12. Okay, so I took that 6, I just moved it to the front. So what do we know about this series? It's geometric. The R value is 3/4. So what's our conclusion then? It converges. Okay, can we find what it converges to? So if I plug in 1, what do I get? 3/4 over 1 minus 3/4. So 3/4 divided by 1/4,
Whoa, it's gonna be
3.
wow.
So if we solve this, we're going to say the sum equals 6 plus 12 times 3, which is 42 feet.
Wow.
overall, we would say the total vertical height or the vertical distance traveled by the ball is about 42 feet.
And
But wasn't that fun though?
Okay, so what?
she said no. Her face.
What did you? No, I'm confused.
So for and using this formula, the top is the first term, so I took this part right here after I took the 6 out, and I plugged in 1, and I got 3/4. And then the bottom of the formula is 1 minus r,
Yeah.
so 1 minus 3/4.
And then you just plugged in like 3 from the end.
Yeah. Yes. Yeah. And then 3/4 divided by 1/4 is 3.